Bitcoin is approaching a rule change deadline that could make different groups of computers disagree about which blocks are Bitcoin. The proposal is BIP-110, a temporary anti-data soft fork aimed at ordinals inscriptions and other large chunks of non-financial data. Could it split the network? Yes, but the most likely split is not Bitcoin breaking cleanly into two equal coins. With miner support still very low, BIP-110 nodes are more likely to stall or follow a small minority chain, while the rest of Bitcoin continues under the existing rules. To understand why, start with the argument that created BIP-110. Bitcoin transactions do more than move coins. They contain scripts, signatures, witness data, and sometimes small pieces of extra information. Ordinal software uses these structures to inscribe images, text, and other files into Bitcoin transactions. Here is a simplified inscription flow. A user selects a file, and an Ordinals wallet prepares transactions that commit to and reveal that data. The wallet signs with the user's private key, proving that it can spend the relevant Bitcoin. The transactions are broadcast, nodes check them, and a miner can include them in a block. Once confirmed, the inscription data becomes part of Bitcoin's history. Full nodes download and validate that block just like any other. Supporters call this a valid use of permissionless block space. The user followed the rules and paid a fee. Opponents call it data abuse. The miner receives the fee once, while thousands of node operators may download, process, and serve the data for years. They also argue that inscription traffic can compete with payments when block space becomes expensive. The dispute grew sharper after Bitcoin Core version 30 changed its default relay and mining policy for op return data. The old default was 83 bytes for the complete op return output script. Version 30 raised the data carrier setting to 100,000 bytes, effectively allowing the normal transaction size limit to become the main ceiling. That change did not rewrite Bitcoin's consensus rules. It changed what Bitcoin Core relays and offers to miners by default. This difference between policy and consensus is crucial. Policy is like a node's inbox filter. One node may refuse to relay a transaction it dislikes, but a miner can still obtain that transaction elsewhere. If the miner puts it in a valid block, every normal Bitcoin node accepts the block. Consensus is the hard validity test. If a transaction violates consensus, an enforcing node rejects the entire block containing it. BIP-110 would move several data restrictions into that harder layer. If active, it would limit most new output scripts to 34 bytes, while allowing op return scripts up to 83 bytes. It would limit many pushed data payloads and witness items to 256 bytes. It would also restrict the taproot annex, deep taproot script trees, undefined witness versions, and certain TapScript features, including op independence opcodes and executed op-ifications. In plain English, BIP-110 does not ask nodes to ignore inscriptions. It tells them that blocks using several popular large data techniques are invalid. The restrictions would last for 52,416 blocks, roughly 1 year, and then expire automatically. Coins created before activation are grandfathered, so the new spending restrictions generally do not apply to those older outputs. If clear Bitcoin explainers like this are useful, subscribe. We focus on what the software actually does, especially when the online argument makes it sound much simpler than it is. Now we reach the showdown. BIP-110 uses miner signaling bit 4 and a threshold of 1,109 blocks out of a 2,016 block difficulty period. That is 55%. If the threshold had been reached voluntarily, the change could have locked in early. It was not. As this script is being written on August 7th, 2026, the public monitor shows Bitcoin at block 961,477, with 2.63% of blocks in the current period signaling. The important deadline is not a calendar date. It is block 961,632, which is still 155 blocks away at that snapshot. Depending on mining speed, the mandatory phase may therefore begin around August 8th rather than August 7th. At block 961,632, BIP-110's enforcing software begins demanding the signal. During the next 2016 block window, those nodes reject any block that does not set bit 4. That is called mandatory signaling, but the name can be misleading. Bitcoin does not contain a universal switch that forces every miner to signal. BIP-110 software can only control what its own users accept. Imagine the next block is mined without bit 4. Bitcoin core nodes accept it because it follows the existing consensus rules. BIP-110 nodes reject it because their new signaling rule says the block is invalid. The two groups now disagree about the chain tip. What happens next depends on miners. If no miner builds on the last block accepted by BIP-110 nodes, those nodes simply stop advancing. Their wallets may appear stuck, with no new confirmations arriving. That is a stalled view of Bitcoin, not a healthy alternative network. If a small amount of mining power deliberately builds signaling blocks from the last shared block, BIP-110 nodes can follow that work. There would then be two chains. One has most of the hash power and follows the existing rules. The other has stricter BIP-110 rules and a small fraction of the mining power. Because the minority chain would initially produce blocks much more slowly, calling this a balanced Bitcoin split would be misleading. It could resemble a small group forking itself away from the network that exchanges, wallets, merchants, and most miners still recognize. There is another possibility. Miners could set bit 4 without actually upgrading their transaction validation rules. Setting a version bit is easy. Enforcing BIP-110 is a separate technical decision. That could keep everyone together during mandatory signaling and force lock-in at block 963,648. The data restrictions would then become active for BIP-110 nodes at block 965,664. If miners continued producing blocks containing transactions that BIP-110 considers invalid, the real split would merely be delayed until activation. This is why miner signaling should not be treated as a simple election. Miners construct blocks, full nodes choose which rules to enforce, and businesses decide which chain they recognize for deposits and payments. None of these groups has absolute control by itself. A user-activated soft fork works smoothly when enough economic users and miners coordinate around the stricter rules. Older nodes can still accept that stricter chain because every BIP-110 valid block is also valid under the old rules. But compatibility works in only one direction. BIP-110 nodes reject some blocks that old nodes accept. If the stricter rules attract only minority mining support, those nodes can isolate themselves. That also explains a common misunderstanding. A soft fork can cause a chain split. The word soft describes backward compatibility under successful adoption. It does not mean the activation process is automatically safe or non-contentious. What about ordinary wallets and Lightning? Standard Bitcoin payments generally fit comfortably inside the proposed limits. BIP-110's own specification was designed to preserve known monetary uses, and outputs created before activation receive special protection. Deployed Lightning channel transactions also appear to fit within the limits. Standard channel outputs are 34 bytes, and commonly used Lightning scripts stay below the relevant data caps. Existing channels opened before activation would benefit from the grandfathering rule when forced closing. The larger Lightning danger is disagreement about the blockchain. A Lightning node watches Bitcoin for channel closures and old channel states. If its Bitcoin backend is following a stalled or losing chain, it may fail to notice something broadcast on the economically dominant chain. A watchtower connected to a different chain could have the same problem. Wallets and services face a simpler version of that confusion. A deposit may have confirmations on one chain, but not the other. Transactions valid on both chains may be replayed. Exchanges and payment processors may respond by pausing deposits and withdrawals, requiring more confirmations or explicitly choosing which node software backs their systems. Then there is the question of whether BIP-110 would actually stop arbitrary data. It would block several convenient techniques, including the straightforward large witness items used by many inscriptions. But it cannot make hidden information impossible. Determined users can divide data into smaller pieces or encode it inside structures that also look like financial scripts. Supporters acknowledge that the restrictions do not eliminate every possible form of data storage. Their goal is to make large, obvious files harder to publish, and to declare that Bitcoin does not officially support blockchain file storage. Critics see that as the proposal's central weakness. If determined users can route around the limits, Bitcoin would accept the risk of a contentious consensus change while restricting legitimate script experimentation, advanced taproot constructions, and possible future upgrades. So the real argument is not simply ordinals versus payments. One side believes neutral transaction rules should mean that valid, fee-paying activity is accepted without judging its purpose. The other believes neutrality does not require Bitcoin to preserve every data-carrying technique, especially when miners collect the fees and node operators inherit the long-term burden. BIP-110 matters even if its minority chain quickly stalls. It demonstrates that publishing a BIP is not the same as changing Bitcoin. Running nodes is not enough by itself. Hash power is not enough by itself. Social media support is not enough either. Consensus appears when miners, users, developers, wallets, and major services converge on the same rules. When they do not, software cannot manufacture agreement by naming a signaling phase mandatory. That is why people are still talking about BIP-110. It turns an argument over inscriptions into a real-time test of Bitcoin governance, and block 961,632 makes that test visible. Do you think Bitcoin should restrict large embedded data, or should any valid transaction be treated equally? Share your reasoning in the comments, and let us know which Bitcoin mechanism we should explain next.